Imagine a place where time itself changes, where 1 second could feel like years, and a single minute could take you to the future or the past. This place exists. It's a black hole. According to Einstein's theory of general relativity, its immense gravity warps space-time. As you get closer, time for you would slow dramatically compared to someone far away. Cross the event horizon, the point of no return, and you're on a one-way trip to the center, the singularity where our laws of physics break down. But what if the singularity isn't an end but a gateway? Some theories propose the existence of a wormhole, a tunnel through space-time that could connect to another time or even another universe. But beware, this journey exists only in the realm of theory and imagination. Are you ready to have your mind blown? Before we even imagine traveling through time, we need to understand the monster of the cosmos, the black hole. A black hole is not just a dark spot in space. It is a region where gravity is so powerful that nothing, not even light, can escape its pull. That's why it looks black. Its gravity is like a cosmic trap, bending everything around it, space, time, even light itself. At the center of a black hole lies the singularity, a point where density becomes infinite, and our current laws of physics break down completely. We can't predict what happens there, but theoretically it is a doorway to the extremes of the universe. Surrounding the singularity is the event horizon, the invisible boundary. Once you cross it, there is no return. It's like crossing a one-way door to a cosmic mystery. From outside, you'd never see anything come back. But black holes are not all destructive. They warp space and time around them. Imagine dropping a marble into a stretched rubber sheet. The deeper it goes, the more the sheet bends. Similarly, black holes bend the fabric of space-time itself, creating the conditions for time to flow differently. There are different types of black holes too. Stellar black holes born when massive stars collapse, and supermassive black holes sitting at the center of galaxies, millions or billions of times more massive than our sun. The more massive the black hole, the stronger its gravity, and the more it can warp time and space. This is where the idea of time travel begins to take shape, but we'll get into that in later parts. For now, remember, a black hole is not just an object, it's a cosmic extreme, a place where reality itself stretches, twists, and challenges everything we think we know about the universe. Now that we understand what a black hole is, it's time to explore one of the most mind-bending consequences. Time itself behaves differently near a black hole. According to Einstein's theory of general relativity, gravity is not just a force, it's a curve in the fabric of space and time. And the stronger the gravity, the more time slows down. Near a black hole, this effect reaches extreme levels. Imagine this. You are an astronaut approaching the event horizon of a black hole, while your friend watches from a safe distance far away in space. To your friend, your clock seems to slow down. Your movements stretch out, almost frozen in time. But to you, time feels completely normal. Every second ticks as usual. This phenomenon is called gravitational time dilation. Near a supermassive black hole, 1 hour for you could be years for someone far away. Essentially, you are traveling to the future not by moving through space, but by being close to extreme gravity. This is not just science fiction. It's been tested with precise clocks on Earth. Clocks at higher altitudes, where gravity is slightly weaker, tick faster than clocks at sea level. Multiply that effect billions of times near a black hole, and you start to see how time travel to the future becomes theoretically possible. But there's a catch. As you get closer to the black hole, the gravitational forces become deadly. Your body and spaceship experience tidal stretching, eventually leading to spaghettification, which we'll discuss in part 3. So while time dilation allows a form of time travel, surviving it is another story. Still, the idea is revolutionary. By harnessing gravity near a black hole, you could witness the future of the universe in a way that is literally impossible anywhere else in space. Time is no longer absolute. It becomes elastic, flexible, and personal, depending on where you are in the universe. So far, we've seen that near a black hole, time slows down, and you could theoretically witness the future of the universe. But there's a dark side to this cosmic wonder. As you approach the black hole's event horizon, gravity doesn't just pull you in, it stretches you. The closer you get, the stronger the difference in gravitational pull between your head and your feet. Scientists call this terrifying process tidal forces, and the end result is something nicknamed spaghettification, Imagine standing upright. Your feet feel a stronger pull than your head, and your body begins to stretch like a piece of spaghetti. Your spaceship, no matter how strong, would also be torn apart. Near a stellar black hole, this happens well before reaching the singularity. Only supermassive black holes are big enough that you might approach the event horizon without being instantly destroyed. But the danger is still real. This extreme stretching shows the limits of black hole time travel. Time dilation could theoretically allow you to jump into the future, but surviving the journey, that's another story. Crossing the event horizon is a point of no return. Once you pass it, all paths lead to the singularity, where physics as we know it completely breaks down. But there's more. Scientists theorize that space and time inside a black hole might be connected in strange ways, potentially even allowing for shortcuts to other regions of the universe. This idea gives birth to concepts like wormholes and closed time-like curves, the foundation of theoretical time travel. So while black holes bend time and offer a glimpse of the future, they also test the limits of survival, forcing us to confront the extreme nature of the cosmos. In Part 4, we'll explore how these extreme warps in space-time might open doors to actual time travel, at least in theory, and what scientists call the cosmic loopholes of the universe. So far, we've seen the extreme forces of black holes and how time slows down near them. But what if there was a way to survive the journey and actually travel through time or space? This is where the idea of wormholes comes in. The theoretical shortcuts through the fabric of space-time. A wormhole, also called an Einstein-Rosen bridge, is like a tunnel connecting two distant points in the universe. Instead of traveling millions of light years, you could, in theory, pass through this tunnel in an instant. Some scientists even propose that wormholes could connect different times, not just different places. Imagine a black hole at one end and a white hole at the other. A white hole being the theoretical opposite of a black hole, where matter and light are expelled instead of swallowed. Entering a black hole could, hypothetically, lead you out through a white hole in another region of the universe, or even in the future. But there's a catch. Wormholes are purely theoretical. To keep a wormhole open, we would need exotic matter with negative energy density, something that has only been observed in tiny quantum effects in labs. Without it, the wormhole would collapse instantly, destroying anything inside. Still, in theory, if a supermassive black hole was connected to a stable wormhole and you could survive the tidal forces, time travel might be possible. You could visit the distant future, or even theoretically the past, though the latter introduces paradoxes that challenge everything we understand about causality. So wormholes are the cosmic loopholes, the universe's theoretical gateways to time travel. Black holes bend time and wormholes bend space. Together they hint at possibilities that are almost science fiction, but grounded in real physics. We've seen that black holes bend time, and wormholes could, in theory, connect distant points in space and time. But how could we actually travel in time? Physicists talk about something called closed time-like curves, paths through space-time that loop back on themselves. Imagine walking in a circle and ending up exactly where you started but years earlier. That's the basic idea. The laws of relativity allow certain extreme solutions where time could loop, creating a potential route to the past. But here's where it gets tricky: paradoxes. The most famous is the grandfather paradox. What happens if you go back and prevent your own existence? Could the universe even allow that? Some theories suggest the Novikov self-consistency principle, meaning anything you do in the past must be consistent with the present. Basically, the universe protects itself from contradictions. Another possibility is parallel timelines. Traveling back could create a new branch of reality, so changes you make wouldn't affect your original timeline. In this case, black holes and wormholes might act as gateways to alternate versions of history, instead of rewriting your own. These concepts are still highly theoretical, and no one has tested them. Yet the equations of Einstein's relativity allow for the math. Black holes, with their extreme warping of space-time, could be the only cosmic objects capable of forming these time loops, at least in theory. So the universe might have hidden cosmic loopholes, where time travel isn't just science fiction. It's a consequence of the same physics that bends time near a black hole. The challenge is surviving, navigating, and understanding these loops before we even think of stepping inside. So far, we've explored how black holes warp time, wormholes might act as shortcuts, and even the strange concept of time loops. But here's the hard truth: the universe doesn't make time travel easy. First, there's the extreme gravity. Near a black hole, tidal forces can stretch anything into a thin line, a process called spaghettification. Even a supermassive black hole where these forces are weaker is still deadly if you cross the event horizon. Surviving a trip through a black hole is for now beyond our technology. Next, there's the problem of energy requirements. Theoretical time travel, like keeping a wormhole open, requires exotic matter with negative energy, something that hasn't been practically produced except in tiny quantum effects. We simply don't have the materials to stabilize these cosmic tunnels. Then comes causality and paradoxes. Traveling to the past could create contradictions in the timeline. Even if closed time-like curves are mathematically possible, the universe might enforce rules that prevent actual paradoxes or limit travel to only the future. Finally, there's the sheer distance and scale. Black holes are far away, and supermassive ones are at the centers of galaxies. Reaching one would take decades or centuries with current technology, if your spaceship could survive the journey at all. Despite these challenges, studying black holes teaches us something profound. Time is not absolute. It can stretch, slow down, and potentially loop depending on gravity. Even if we can't travel tomorrow or revisit yesterday, black holes are natural time machines that reveal the universe's deepest secrets. So far, we've explored the harsh realities of black holes and the theoretical ideas of wormholes and time loops. But what if we let imagination meet physics? Could humanity one day use black holes to travel through time? Some scientists speculate about artificially created or controlled black holes. If we could somehow generate a miniature black hole and stabilize it with exotic matter, it might act as a manageable time machine. Of course, this is far beyond today's technology and extremely dangerous. Science fiction often imagines spaceships orbiting supermassive black holes to exploit time dilation. In theory, a crew could spend a few hours near the event horizon and return to Earth decades or centuries in the future. Movies like Interstellar have even visualized this concept, showing how gravity near a black hole stretches time dramatically. Another futuristic idea involves wormhole networks. Imagine a network of stable wormholes connecting different points in space and time. Humanity could travel across galaxies in an instant, or even witness the universe's past events. Again, this requires exotic matter and extreme precision. One miscalculation could collapse the tunnel and obliterate everything inside. These scenarios are speculative, but they show the potential of black holes as cosmic tools, not just destructive monsters. They challenge our understanding of time, space, and our place in the universe. Even if we never achieve it, exploring these possibilities helps us push the boundaries of physics and imagination. Black holes may promise time travel, but they are also the ultimate cosmic hazards. Even if we could approach or enter one safely, the dangers are extreme. First, there's spaghettification and extreme tidal forces. No human or spaceship could survive a close encounter with a typical black hole. Supermassive black holes reduce this risk, but only slightly. Then come the paradoxes. Traveling to the past could create contradictions, like the grandfather paradox, where changing past events threatens your own existence. Could the universe allow this, or would some cosmic law prevent it? The answers are uncertain. Some theorists suggest parallel timelines could resolve the paradox, but that opens an entirely new set of questions about reality itself. Philosophically, black hole time travel challenges our understanding of cause and effect. If time is flexible, is the future predetermined? Are we bound by a fixed timeline, or is everything possible in a multiverse of branching realities? Even imagining such journeys forces us to confront the limits of human perception. Our experience of time is linear, but black holes show us it can stretch, bend, and loop. Time travel might not just be a physical challenge, it's a mental and philosophical one. Ultimately, black holes are cosmic mirrors. They show us how fragile our concepts of time, cause, and reality are, and how daring it would be to try to navigate the extremes of the universe. In the next part, we'll explore the most mind-bending possibilities of escaping into the future or beyond. While traveling to the past is filled with paradoxes, one of the most realistic forms of black hole time travel is moving forward into the future. Near a black hole, time slows down drastically due to gravitational time dilation. If you could orbit safely close to a supermassive black hole for a short period, while staying alive and avoiding spaghettification, the rest of the universe could experience decades or even centuries in the blink of an eye for you. Imagine this. A spaceship orbits the black hole for a few hours, performing experiments, sending messages home, while Earth ages decades. You return, and humanity has changed, cities have evolved, civilizations may have risen or fallen, all while you have barely aged. In a sense, you have witnessed the future firsthand. This isn't science fiction. The math of Einstein's relativity supports it. In fact, scientists have observed small but measurable effects of time dilation near Earth itself, using precise atomic clocks. Black holes are just the ultimate magnifiers of this effect. Some theorists even suggest orbiting binary black holes or regions with multiple massive objects could create even more extreme time dilation, allowing future exploration on cosmic timescales. You could see the universe evolve far beyond the lifespan of any human civilization. The idea is both thrilling and humbling. By bending time near a black hole, we could become time travelers of the future, observers of a universe unfolding in ways no human has ever witnessed before. The final part 10, will tie everything together and explore what black holes ultimately teach us about time, space, and our place in the cosmos. We've journeyed from the basics of black holes through extreme gravity, spaghettification, wormholes and time loops, all the way to imagining escaping into the future. But what do black holes truly teach us? First, they remind us that time is not absolute. Near a black hole, seconds stretch, minutes expand, and years can pass outside while you barely age. The universe is far stranger than our everyday experience. Second, black holes show the limits and possibilities of physics. They are deadly yet beautiful, destructive yet potentially transformational. They bend space and time, challenge causality, and hint at the extraordinary connections between different points in the cosmos. Third, black holes inspire imagination and curiosity. Even if we can't survive inside one or stabilize a wormhole, exploring these ideas pushes humanity to think bigger, question reality, and explore the unknown. Finally, they leave us with a humbling truth. In the vastness of the universe, time, space, and life are fragile and interconnected. Black holes are more than cosmic vacuum cleaners. They are time machines, teachers, and gateways to understanding our universe at its deepest levels. So whether through extreme time dilation near a supermassive black hole, theoretical wormholes, or cosmic time loops, black holes remind us that the universe is full of mysteries waiting to be explored. And who knows, maybe one day we'll travel not just through space but through time itself, guided by the gravity of these cosmic giants. Until then, black holes remain one of the greatest invitations to dream, imagine, and explore the ultimate frontier of time and space. Black holes teach us that time is not absolute, that physics has extreme possibilities, and that imagination is key to understanding the universe. They are deadly, mysterious, and beautiful, warping space, bending time, and hinting at alternate realities. Even if we never travel through one, they inspire curiosity, exploration, and the courage to ask, what lies beyond the edge of reality? Black holes are not just cosmic monsters. They are time machines, teachers, and gateways to understanding the deepest mysteries of our universe.